This video is more about gradient functions. Gradient function also derivative of functions. So let's go to number 6. Point Q lines the curve of this. The gradient of a curve at Q is equals to 13. Find the gradient function of the curve. Gradient function basically means f prime of x. So remember, here's the rule. Ax to the nth power rule. Coefficients stay. This exponents drop down minus 1, like this. So you will get, let me write down here for the A part. 3x squared, 3 is coefficient, then 2 drop down x to the first power, minus, remember the derivative for x equals 1, constant number equals to 0, so you get the minus 1, then plus 0. Organize, you got the 6x minus 1. For B, find the x coordinate of Q. We know the gradient of the curve at Q is equal to 13. In other words, you got this f prime of x equals negative 13. You need to solve for this x. So you get the 6x minus 1 equals negative 13. I add 1 both sides. You will get negative 12. So x equals negative 2. That's for B. For C, find the y coordinate of Q. Since you already got this x, how you get the y coordinate, you just need to substitute the negative 2 into the original function. So you get the 3 times negative 2 squared minus negative 2 plus 1. Negative 2 squared is 4, so 13 plus 2 plus 1, you will get the 15. That's for number 6. Let's go to number 7. Point P, A1. That's the coordinate where a greater than 0 lies on the curve of this. Find the value of A. They give you the point, that means you know the xy. That means your x1 equals A, y1 equals 1, right? In other words, when you plug in A into the function, you are supposed to get 1. So I put the A into this function. Every single x need to change into A. So we get the A squared minus 4A minus 4 equals to 1. This is a quadratic function. Therefore, try to get the equal 0. Move every single term from right side to the left side. Then remember you need to change the sign. Negative 4 minus 1. So you get the A squared minus 4A minus 5 equal to 0. If you do the factor, this is over 1 over 1, negative 4. So for negative 5, you will do 1 times negative 5. Adding is negative 4, so this is your answer. You get the 1, negative 5. Here's A, this is A. Bottom up, you get the A plus 1, A minus 5 equal to 0. Therefore, A1 equals to negative 1 and A2 equals to 5. Here, since A is a positive, that's why we take this. This one we cross out. A equals 5. Let's go to B. Find the gradient function of the curve. Gradient function means a derivative function, so f prime of x. Remember, here's the rule. Drop down minus 1. Therefore, we work on the first term, x squared, that is 2x, minus 4 plus 0. Remember, for x, the derivative equals to 1, constant number equal to 0. So you get the 2x minus 4. That's the gradient function. Let's go to say, show that at P, the gradient of curve is equal to 6. Gradient of the curve is equal to 6. In other words, we are looking for the derivative when x equals to 5, because this one is a 5. We do f prime of 5. We plug in here. 2 times 5 minus 4 equals to 6. That's it. Show that. That means you have to show the work. How did you get this answer? For this one, for number D, point Q, CD is also on the curve at which the gradient of curve is equals to 8. Show that D equals 8 too. Gradient, that means we need to f prime of C. You are supposed to get 8. So we plug in here. You have 2c minus 4 equals to 8. 2c equals, add 4, cross this equal sign, change sign, 12. C equals 6. We need to show that it's a D equals 8. How you get the D? We know the Q is a CD. In other words, F of C equals D. So D is you need to plug in this C into the original function. That is f of 6. What's the original function? This is the original function, x squared minus 4x minus 4. So we plug in 6 into that x, or substitute 6 into that x. That is 6 squared minus 4 times 6, then minus 4. So you get 36 minus 24 minus 4. You will get 8. IB exam, whenever you see that, show that. You have to show all the steps, how you get that answer. Let's go to the last question. Consider the function this. Write down the derivative. Yeah, that's kind of easy. Show that at x equals 1, these two equal. So for A, the derivative of function, that is we using the power rule. A times n, x is n minus 1's power. So you get the 5 times this 2, you have to drop down minus 1, x to the first power minus. Remember, x derivative equals 1, so minus 1. Constant number is 0. So we get 0. Organize, you will get the 10x minus 1. That's for A. For B, we want to figure out at x equals 1, these two equal. So we're working on f of 1. We need to substitute into the original function 5 times 1 squared minus 1 plus 5. So you will get 9. Then f prime of 1 equals 10 times 1. I need to substitute into the derivative function, minus 1 equals to 9. So using this one, that means therefore f of x equals to f prime of x 1, x equal to 1. Let's go to C. Find the coordinate of a second point on the curve for f of x equals f prime of x. We know that f of x equals 5x squared minus x plus 5. F prime of x, we already figured out that's 10x minus 1. So we will set up these two equal. Let's write down that it's a 5x squared minus x plus 5 equals 10x minus 1. Therefore, we know this is a quadratic pattern equation. Move everything to the left side. Remember, change the sign. So you get the equal to 0. 5x squared minus x plus 5 minus 10x plus 1. You will get 5x squared, combine like terms, minus 11x plus 6 equal to 0. Let's do the ninja x. We do this is a 30. Here's a negative 11 over 5 over 5. 30, you can do, this is a 130. No, adding is not 11, so we do 215, not 11. 310, not 11. 5, 6, yeah, that's 11, but we need a negative 11. That's why we do the negative 5, negative 6. Negative 5, negative 6, reduce here, negative 1, 1. Then we put the x. You will factor as x minus 1 and 5x minus 6. Now let's factor is x minus 1, 5x minus 6 equal to 0. Therefore, your x1 equals to 1. x2 equals 6 over 5. We only get the x, but they said coordinate. Therefore, you didn't finish yet. You need to substitute the 6 over 5 into original function. So 5 times 6 over 5 squared minus 6 over 5 plus 5. If you use a calculator, you will get 11. Therefore, 6 over 5 or 11. That's the coordinate of a second point.